Hi guys. So today we're going to look at some properties of logs. These are going to be very similar to some of your exponent properties, and we're going to apply these to logs to be able to expand them, condense them, and just rewrite them in different forms. So there were three major properties that you need to understand for logs. One of them is the product property, okay? So if you have multiplication within the argument of a log, you can actually expand that into two logs that are being added together. So instead of m times n in the argument, it becomes the log of m plus the log of n. Now, if you think about that, that's pretty similar to your exponent rules. Whenever you had something to the, let's say you had b to the first times b to the seventh, you added those exponents together. Okay, so when I was multiplying the bases, I added my exponents. Okay, so similar property here. Whenever you have multiplication in your argument, you can add those logs. Quotient property, again, kind of follows the same rules. When you have division in the argument, you can separate that into subtraction of your logs. Okay, because again, if you had like x to the fourth over x squared, you could subtract those exponents. Then finally, if you have the power property, again with exponents, if we had x squared to the fourth, we multiplied those exponents. So if you have an exponent on your argument, you can take that exponent and multiply it in the front. So these are three really important properties for logs that we're not only going to use today, we are also going to use these once we get to solving. Okay, so it's going to be really important for you guys to be comfortable with these. So the first thing we're going to do is we're going to go the opposite way. We're going to take multiple logs and condense them into one. I think these are a little bit simpler than expanding. So your goal here is we're just going to write the word log one time, and then we're going to deal with our arguments. So if I'm adding logs, then I can multiply the arguments. So log a plus log n becomes the log of a times n. Okay. If you want to put parentheses around it so you know that that's the argument, that's okay. But again, a n now multiplied is my argument. With these values, okay, a number in front becomes the exponent on that argument. So this is now log 9 plus the log of 2 to the third, which is 8, minus the log of 3. Adding logs, we would multiply, so this is the log of 72 minus the log of 3. If you are subtracting logs, you divide the arguments. So this would become 1 log, and then I would divide the arguments. Okay, so this is 72 over 3. Oops, that was an eraser, which would be the log of 24. All right, if you feel pretty comfortable, pause the video, try C. Okay, all right, so again, bring those exponents first. So this would be the log of x to the 1/2, which we know is the square root of x, minus the log of y squared, minus the log of z to the third. Okay, so we went ahead and moved our exponents. Now we'll go ahead and follow this order here. Okay, so it's the log of the square root of x minus the log of y squared. So that means division, so I would divide the arguments. Okay, so dividing just the arguments. I'm not dividing the logs, I'm just dividing what we're taking the log of. So this is the square root of x over y squared. All right, I still have minus log z cubed. Since it's minus, we would again divide, so that z cubed would go to the bottom. So at the bottom of this fraction, I'm going to have z to the third. All right, and then let's look at the last one. I think probably a common mistake here is that people want to distribute and say that this is natural log of a plus the natural log of b. We know that's not true because using that property, the natural log of a plus the natural log of b is the natural log of a times b. So you cannot distribute there. Okay, so do not distribute those values. Actually, there's nothing we can really do to change this, okay, because there's no property about addition within the argument. The only thing we can do is because this log and this log are being added, we can multiply those arguments. So this would become the natural log of a plus b times a minus b. and then it's going to be minus the natural log of c squared. Put another parenthesis on there. All right, so then if I want, I can go ahead and multiply that out. A plus b times a minus b is a difference of squares, so that's a squared minus b squared. Just makes it a little easier to see. And then because I'm subtracting logs, I would divide, again, I'm dividing the argument. I'm not dividing the actual logs. Okay, so I'm going to have the natural log of a squared minus b squared over c squared. All right, so now let's go the opposite way. We're going to take a condensed log and expand this into multiple logs using those same properties. All right, so if I have multiplication, that becomes addition of multiple logs. So this would be the natural log of 5 plus the natural log of x to the 7th. Then if I have division, that becomes subtraction of a new log. So this is going to be minus the natural log of y. Then the last thing I can do is that exponent, I can move to the front. So I can make this the natural log of 5 plus 7 natural log of x minus the natural log of y. All right, so let's look at b. Okay, one thing to be careful about here. This is not 3x in parentheses to the 4th. So that exponent of 4 is not being applied to the 3. 3 is being multiplied by x to the 4th. So that means to separate this, I'm going to separate this into addition. So this is going to become log base 6 of 3 plus log base 6 of x to the 4th. Now I can move that 4 to the front. So this would be log base 6 of 3 plus 4 log base 6 of x. All right, c, which I wrote twice. All right, I have log base 3 of 5. Because there's subtraction, or because there's division, it's going to become a subtraction of a new log. And there's two ways that you could write this, okay? 12x is 12 times x. So I could say that this is subtracting the log base 3 of 12 plus the log base 3 of x. And as long as it's in parentheses, that will work. You also, if you avoid those parentheses, you can rewrite it similar to the example we saw when we were condensing, and I can make both of these minus, and that's telling me that both of those values would be at the bottom of our fraction. So either of these things is okay. Okay, you could write this either way. All right, and then our last one, okay? Remember, square root is 1/2 as an exponent. So this is log base 5 of x minus 1 over x plus 1. I don't need parentheses on that. Okay, that is to the 1/2 power. So both of those have that 1/2 exponent. So I'm going to move that 1/2 exponent to the front. Then, because there is division in the argument, I can separate that into subtraction of logs. But, again, x minus 1 has to stay x minus 1 in the argument. X plus 1 has to stay x plus 1 in the argument. So this is going to become 1/2 log base 5 of x minus 1 minus 1/2 log base 5 of x plus 1. If you wanted to just put the 1/2 once and put parentheses, that would also work. Either of those forms is okay. But make sure you know that both of these logs are being multiplied by that 1/2 out in front. Okay, and again, if you have addition and subtraction in the argument, there is nothing you can do with that. You're going to leave that as addition and subtraction. All right, so what we can use these properties for is to evaluate logs knowing just certain values. So what I'm going to try and do is I'm going to try and rewrite this log into one of these two forms using my properties. So log base 3 of 4/5, I know that that's the same thing as log base 3 of 4 minus log base 3 of 5, because division in the argument becomes subtraction of your logs. So log base 3 of 4, I can now replace with 1.262. Log base 3 of 5, I can replace with 1.465, which gives me a negative 0.203. And if you were to evaluate that log, you get something pretty close. Now our value might be a little bit different just due to rounding, but this is the process that we're going to use here. Okay, so let's think of how we can get log base 3 of 100. Well, log base 3 of 100 would be the log base 3 of 25 times 4. So log base 3 of 25, that's the same thing as log base 3 of 5 squared plus log base 3 of 4. 5 squared, I can move the 2 to the front, so now I have 2 log base 3 of 5 plus log base 3 of 4. So now I can replace those values. So this is 2 times 1.465 plus 1.262, which gives me 4.192. Looking at C, okay, we actually already did that within that problem. There's two different ways you could write this. You could do this as log base 3 of 5 plus log base 3 of 5, or you could do it as 2 log base 3 of 5. Either way, you're going to get the same answer. You're going to get 2 times 1.465, which gives you a value of 2.93. And then the last one, log base 3 of 1 over 16. This uses, we need to know our exponent properties here. This is the same thing as log base 3 of 4 to the negative 2. Because if I raise 4 to the negative second power, that would make it a fraction of 1 over 16. So now I can take that exponent, move it to the front, so negative 2 log base 3 of 4. So this becomes negative 2 times 1.262, which is negative 2.524. So again, the goal here is to rewrite this value using your properties, either with addition, subtraction, or your powers, all right, to put it in the form of the logs that you do now. So one last property of logs is something called the change of base formula. So the change of base formula is actually something that you would need to use if you had to evaluate this log and your calculator wasn't able to give you a different base. It's also helpful sometimes for simplifying expressions where bases and arguments match up. So you can rewrite change of base formula using any base you want. You can use log with a base 10, you could use a natural log. If you want to, you use a base of like 30. But typically we do this using the common log and the natural log because those are the ones most commonly used and easiest to evaluate with your calculator. So the way change of base formula works, you take basically any base you want. Again, typically we'll use just regular log or ln. Then you take the log of the argument on top and then the log of the base at the bottom. Okay, so I would rewrite log base 3 of 8. If I want to rewrite this using the regular log, it's the log of the argument divided by the log of the base. What's important to notice here, this is not the same thing as the log of 8 over 3. The log of 8 over 3, that uses those log properties where it's log 8 minus log 3. Okay, which means that this log is not the log of 8 minus log of 3 because again, this is an entire log divided by another log. It is not division within the argument. Okay, now we can go ahead and actually evaluate this on our calculator. So let's go ahead and do this. Okay, so I'm going to do log 8, and let me go ahead and do it as a fraction. So log 8 over log 3. And then if I went ahead and did my log AB, okay, log base 3 of 8, you guys can see that you get the same value. All right, and then again, you can use any base you want. So if I wanted to use natural log, the natural log of 8 over the natural log of 3, I still get the same value. All right. So if you feel pretty comfortable, go ahead and pause the video, try these last two, but I'm going to go ahead and finish these up. All right, so again, I would rewrite this one as ln 8 over ln 3. And like you guys saw, we just evaluated that one in the calculator to get our decimal. So this one was 1.893. This was 1.893. B, I would rewrite as it's the log of the argument divided by the log of the base. And then again on B, log of the argument divided by the log of the base. If you plug that in your calculator, this would be 1.232, and this would be 4.248. All right, the last thing is just an example using those properties of logs. Okay, so one log function that has some real-world application here is looking at decibels and sounds. So this equation here, okay, helps us to determine basically the intensity of sound. Okay, so that I sub naught at the bottom is the intensity of a barely audible sound. All right, and it helps us to figure out, basically we can use this to compare intensities when something's turned up. So what we're going to do, it says an artist in a recording studio turns up the volume of a track so that the intensity of the sound doubles. Okay, so what we're going to do is we're going to rewrite this expression using that information. So if it doubles, I'm going to, and this is a 10, I'm going to have my original equation, but because it doubled, it's going to be twice the intensity. Okay. Now I don't know what I and that I sub naught are, and that's okay, because I'm just going to see how I compared it to the previous sound. So if it doubled, then the previous sound is not going to be 2 at the top. It's going to just be that I value. All right. So then using our properties of logs, one thing we know, well, both of these have 10 out in front, so I'm just going to go ahead and take that 10 out. All right. Well, then using our log properties, what I'm going to do, this is 2 times I. So since it's 2 times I, or 2 times I over I naught, either way, I can separate that using my log properties. So this would become log 2 plus log I over that I naught. And then I still have minus log I. Okay, so again, these are just the expanded form of this log because it was 2 times that. Well, now that I've rewritten it, these logs here are the same, which means they're going to cancel out if it's plus and minus. So all I'm left with now is 10 log 2, which is something I can evaluate using a calculator. And I would end up with 3.01. So it's going to be about 3 times the intensity. All right. So again, these properties for expanding and condensing are going to come back up when we do solving. So make sure you're comfortable with both expanding these logs and condensing these logs using those properties.